Hello everyone and welcome back to this video series. In this video we are looking at grade 12 mathematics paper 1 from November 2016. We're going to try and get through question 2 and question 3 of this paper. So question 1 has been done in a separate video. Question 1 was just some linear algebra, simultaneous equations, and quadratic equations, or factorizing and solving. Now in question 2, it looks like we have some sequences in series, and same for question 3. So we're going to try and do these two questions together because they're quite similar. I'll just remind everybody, as I often do, you have 180 minutes to do this paper, and the paper is out of 150 marks. So often you want to work at a rate of 1 minute per mark. This leaves you with 30 minutes extra at the end to double back through your work and double check everything and do questions you may have skipped. Yeah, so that is our general approach. There's often about 11, sometimes 12 questions on these papers. Just depends. I will say that so far this 2016 paper has been a bit harder, so I would expect that the papers this year in 2024 wouldn't be as hard as this one. So this is good practice to get in the right space, the right mood for maths paper 1. Okay, so let's start with question 2. Okay. So given the finite arithmetic sequence, so 5, 1, minus 3, blank, negative 83, negative 87. Okay. So there's quite a couple terms here that they've left out. That's what the 3 dots mean. So there's like quite a couple terms. So we can see it's changing by 4. Yeah. We're basically subtracting 4. So negative 4 in each case. So the missing numbers, I mean, we can put in a few: negative 7, negative 11, negative 15, and all the way to negative 87 as the last term. And they told us it's finite. So we go from 5 to negative 87. That's the whole series. Okay, write down the 4th term of the sequence. Okay, so yeah, this is pretty straightforward. We already have it. We just say, so T4 equals negative 3 minus 4, which equals negative 7. Okay, so T4 is negative 7. That's good for 1 mark. You don't even have to do the work. I mean, it should be pretty obvious that the next term is negative 7. You can just write the final answer down. Good. Calculate the number of terms in the sequence. So there are a couple of ways to do this. You can just, yeah, I mean, it's going from 5 to negative 87 with a difference of negative 4. So you can sort of like you can do this a couple different ways, but we'll do it the proper way. So if it wasn't an as straightforward sequence, then how would we figure out the number of terms? Maybe if it's like really large, or we don't know exactly what all the terms are or anything like that. Like, let's just say it's a more complicated case. what we would do, the more robust way of approaching this, is to use our formula Tn. So the nth term is equal to the first term plus the change minus 1, or the term, whichever term minus 1, multiplied by the change. Okay, and let's plug in some values. So we know it goes from 5 to negative 87. So let's figure out what n is for, so what the nth term is for the value of negative 87, because that'll give us the total number of terms indirectly. Okay, and our first term, of course, is 5. And we don't know what n is. We're trying to figure out what n is, right? The number of terms. And then our change is negative 4. Okay, so this would be the more robust way of doing it, and then you just solve for n. So what do we have? We can take the 5 the other side. So we would have negative 93. And then here we would have negative 4n plus 4. And then we can take the 4 the other side as well. So negative 97 equals negative 4n. And then did I do this correctly? Oh, it's supposed to be 96, not 97. Just did my math wrong there. And then we divide both sides, and we would get n equals 24. So there's 24 terms. So yeah, I mean, if you know what the last term is and what the first term is, you can use this formula to find the number of terms in the sequence. Other ways of doing this, I mean, yeah, you can sort of like figure out the maths. I mean, you can say something like negative 87 minus 5, and then you get like negative 93, and the difference is like negative 4. And you would do this, and then you would sort of like have to round up. You'd get 23 point something something, and then you round up to 24, right, to get the number of terms. So this works because you know the first and last term. So this is like one way of doing it. It's not proper, but it will get you close to the answer. The proper way would be to definitely use this equation. Yeah. Okay. Let's go to the next question. Calculate the sum of all the negative numbers in the sequence. Okay, so we know what formula we can use to calculate the sum of the sequence. Let's just rewrite the sequence with only the negative numbers. So we would start at negative 3, go to negative 7, all the way to negative 87. Okay, so that's our new sequence with only negative numbers. And then we're going to calculate the sum, yeah? So the equation we can use for this is Sn equals n over 2 a plus Tn. Okay, so you need to realize that here we had said there are 24 terms, and we've removed 5 and 1. So now we have 22 terms. So this is the sum of 22 terms. Okay, so again, n is 22 over 2. Our first term is negative 3 plus Tn, which should be the 22nd term, is negative 87. 2 square brackets. And then you just solve for this, yeah? So we can do it together. Inside we have negative 90, 22 over 2. That's 1, that's negative 45 times 22. You can use your calculator to say 22 times negative 45, and you get negative 990. And that's the answer. Okay. If you don't redo the series like this, I mean, you can just like do the sum for this given series, and then you just subtract 5 plus 1, which is 6. So you can just do the sum for the first series, and then just subtract 6 from it, and you would get back to this answer. So both ways work. For these questions, I mean, there's a couple of ways to do it. So I prefer just to like show maybe I'd say the way most people would do it. But of course, if you feel like there was a different way of doing it, doesn't mean your way is wrong. By all means, do the way that makes the most sense to you. Okay, so it seems like they give us the same sequence, but then the numbers now don't end at negative 87. It now ends at negative 4187 before we're ending at negative 87. Okay, so they've made the sequence a lot longer. So they say determine the number of terms in the sequence that will be exactly divisible by 5. Okay, exactly divisible by 5. All right. So there are definitely a lot of ways one can approach this. Maybe we'll look at 1 or 2 different ways, or we'll just look at one way. It is worth 4 marks, so bit of a tough question. But let's think about this. So we have 5, 1, negative 3. Okay, negative 83, negative 87, negative 4187. Okay. Yeah. Tricky. Tricky. So the first approach that you can use to do this is you can sort of like come up with another sequence where what you need to realize, and I suppose that's what makes this question difficult. What you need to realize is our change is 4. Yeah, this is what our change is. So d equals negative 4. And for something to be divisible by 5 in our sequence, right? So we want to know what is divisible by 5. By 5. The only numbers that will incorporate our change of 4, so it has to be something that can be divided by 4 as well, and divided by 5 as well. That means the lowest common multiple of 4 and 5 is 20. I don't know if the lowest common multiple will be 20. I suppose the negative positive signs don't really matter for now. So basically, we can come up with another sequence that has a change of 20 within the range from 5 to negative 4187. So we want to know how many numbers are multiples of 20 in that sequence, or yeah, multiples, I suppose. And then that will tell us exactly how many numbers in our original sequence are also divisible by 5. Yeah. So I guess that's the tricky part. The tricky part is to see that we can make another sequence that is multiples of 20 and then use that within the range of this sequence, so from 5 to that number, in order to get the number of terms divisible by 5. It's a bit tricky. I will say, like, most people wouldn't think to do it this way. There are a couple other ways of doing it, to be honest. Like, there's ways where you can do it with like a lot of algebra. You can use inequalities. Yeah, the sky's the limit with I think, yeah, there's at least 3 or 4 different ways I can think of doing this, but this one is definitely the quickest, the shortest. It requires the least. If you can understand this part, then the rest of it makes a lot of sense. This is the hardest part, to just see this. Once you see this, then the rest becomes obvious. For the other questions, like where you use inequality, I mean the other methods where you use inequalities and algebra, yeah, those have lots of steps, and yeah, in my opinion, they're a bit harder. So I'd say this is like the quickest way. Okay, so let's do it. So basically, we're gonna have a sequence that looks like this. Okay, and d equals -20, as we said. So then let's figure out how many terms would be in this sequence, right? So tn equals, so our first term, so what we need to realize here is that, what's our first term? Okay. So we'll use, okay, we're kind of rewriting it, I suppose. I mean, I don't know, I guess it doesn't matter. We'll write it in another way. It's fine. So when we plug in our values, we will have something like this. I hope you can see this. Yeah, of how we get here. Just take a second to convince yourself that this makes sense, that you understand it. And then the point is, now we need to figure out what the last term in the sequence divisible by 5 is. And that would be, we can do it on the side. So our last term is -4187. And then the last term divisible by 5, we can add what? We can like add 12 here, I think. So it'll be the third from last term. And we should get -4175. This should work. Then we can plug in this number back in here to figure out what term that is. So -4175 equals -20n plus 25. And then we just solve for 20. Okay. And then move some stuff around. We can get 20n equals 4200. And n equals 210. So that's how many terms are divisible by 5. So okay, we did this very short. So take some time to convince yourself that our series makes sense, and that our equation for, well, our sequence makes sense, and our equation for the sequence makes sense. And then we figured out the last term that's divisible by 20. I hope you agree with me that it is 4175, -4175, and then we plugged it in and we figured out what n was. Okay, So definitely for this question, think about it and it should make sense to you. You need to convince yourself that this is okay. Like I said, there's a lot of different ways of doing this, but this is the most straightforward one. The other ways involve inequalities and setting up a whole bunch of equations to try and get things to make sense. It's a lot more complicated. But okay, that was question 2. So 11 marks in the bag. Nice. Let's have a look at question 3 and see what we can do with question 3. The first 4 terms in a quadratic pattern are given. Okay. So we don't have an arithmetic sequence anymore. We now have a quadratic. So we know we're going to be using maybe the geometric sequence equation at some point in this question. Okay, good to know. So it says calculate the values of x. So for this one, I mean, we don't need to try and set up some complicated equations. Maybe we can just use some logic. Let's see. So we have -1 x 3 x plus 8. Okay. So what's the difference? So what we can say here is we can say x minus -1, which is just the same as x plus 1. Okay. And then here we can say 3 minus x. And then here we can say x plus 8 minus 3, which just becomes x plus 5. Okay. And then as we know in geometric sequences, we have to find the common ratio between the differences, yeah? So we'll do it again here. And we get 3 minus x minus x plus 1. And what do we get here? So minus x, and this, so remember this negative sign will distribute to the x and to the plus 1. Okay, so it's minus x, which is minus 2x, and it's 3 minus 1, which is 2, right? So plus 2. Okay, and let's do it again. So it's x plus 5 minus 3 minus x. Okay, so again, so the negative distributes throughout the entire term. Okay, so just be clear on that. So we have x minus x, which is like x plus x, which is 2x, right? And then we have 5 minus 3, which is plus 2. Okay. And then what we can say is that we know that these two are supposed to be equal. Okay, so we can set up an equation. We can say negative 2x plus 2 equals 2x plus 2. Okay. And straight off the bat, these cancel. If we bring this negative 2x to the other side, so we get 4x equals 0. Therefore, x equals 0. Okay. So, yeah. So when they ask us the values, calculate the value of x here, x just equals 0. So that's just 0 and that's just 8. Okay. All right. Pretty cool, pretty cool, pretty cool. Okay, let's make some space here. Good. Still got some stuff here to get rid of. Okay. If x equals 0, determine the position of the first term in the quadratic number pattern for which the sum of the first n first differences will be greater than 250. Wow. Okay. So let's see what we can see from our pattern here. First of all, let's understand something. So we have -1, 0, 3, 8. So our differences here is 1, 3, 5. Okay. So we can sort of like set up another sequence here. Yeah, we can see we have a sequence in a sequence basically, and that's what geometric sequences really are. So here we can see that our common change is always 2, right? So we can use a sum of sequences, this one, to just calculate what the question is asking. Yeah. So let's set it up. So Sn equals n over 2. Our first term is 1. No, our difference. Yeah, difference is 2. Yeah. Okay. And then n minus 1. Now difference is 2 here. So this is what we have. Our first term is 1. Okay. And then close it up. And then what can we see here? Here we have to do some maths to see what we can see. Let's see what we can see. So we're gonna have 2 plus 2n minus 2. Okay, so these 2's cancel. And then we're gonna have n over 2 on the outside. And then these 2's cancel. And it's n times n, so it's n squared. So Sn equals n squared. Okay. And we want to figure out what n would be. And they give us a limit. So they say greater than 250, right? They say the first differences will be greater than 250. So Sn is 250. And we want to figure out what n squared would be that's greater than n250. Okay. And then we need to figure this out, right? So, and we can just take the square root on both sides, yeah? So then we'll say n would be greater than 15.8 or 16. You can just round it off. So then we would say the sum of the 16 first differences will be greater than 250. Therefore, the 17th term of the quadratic number pattern is the first satisfying condition. So here you can just say 16 because it has to be a whole number. And then to answer the question, so the first term that satisfies this is actually T17. Okay. So you just got to remember what the question is actually asking you. So if you stop at this, you'll lose 1 mark because the answer answer is 17. So you need to then take it back and realize that then the first term that satisfies the condition is the 17th term. But yeah, this is very simple. Very, 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 very nice question. Forces us to think. is an elegant solution. You can do this a couple other ways, to be honest, but that would be very long and time wasting. This is the most straightforward approach. Okay, let's look at question 3.2. Rectangles of width 1 centimeter are drawn from the edge of a sheet of paper that is 30 centimeters long, such that there is a 1 centimeter gap between one rectangle and the next. Okay. Okay, well, they give us a diagram at least, so it's easy to understand what they mean. The length of the first rectangle is 21, okay, and the length of each successive rectangle is 85% the length of the previous rectangle. Until there are rectangles drawn along the entire length of AD. Each rectangle is colored gray. Okay. Calculate the length of the 10th rectangle. Okay, so this is very straightforward. I mean, they give it to us as a percentage, but this is really this is our ratio, our R value for our equation. So we're gonna use Tn equals AR n minus 1. So what we need to, okay, maybe let's write down the sequence. So the sequence is 21 is our first term, plus 21 0.85 plus 21 0.85, and then we can just say squared, yeah, because it's when what you're saying is, in this case, we're gonna figure out 21 times 0.85, and then whatever the answer of this is, let's call it x, we're gonna do it again, x times 0.85. So because we're basically multiplying by 0.85 twice, to write it in the sequence, we can just say 0.85 squared, and it makes sense. Okay, and you can keep going. I mean, you can do it again, 0.85 cubed, and then just keep going. Okay, so yeah, so that's step one. Step one is just to figure out what the sequence is. This is the sequence. What equation are we using? We're using this equation, yeah. And R, of course, is 0.85, A is 21, and we want to figure out the 10th term. So the 10th term would look something like this, yeah. Plug this into your calculator and you get 4.86. Then of course it is centimeters, so you should include the units, and that's the answer. Okay, calculate the percentage of the paper that is colored gray. Wow. Okay, this is a tricky question. We're going to have to think a bit on how to do this. So what can we do? First, we need to figure out how many rectangles can we actually fit on this paper. So it basically takes 1 centimeter and then 1 centimeter of space, so 2 centimeters for a rectangle. And we have 30 centimeters total between AD. So that means we can only fit 15 rectangles. Okay, and you get a mark for figuring this out, so do write it down. You will get a mark. This question's out of 4 marks, so you want to write down as much as you can to try and get marks. So you will get a mark for figuring out that it's 15 rectangles. Now, we know with each term, we're getting the length, and we know that they all have the same width. So we can figure out the area. We can do a sum of the sequence to figure out the total area of our rectangles, because we'll just multiply all of them by 1 to get the area. So that's fine. And we can figure out the total available area of this sheet by saying 30 times 21. And then we can take a percentage to see how much of the paper is actually gray. Okay, so we have a strategy. So let's do it. We now have a strategy. So let me make some space. Okay. So first things first, let's do a sum of the 15 rectangles. So we'll use the equation for sum of a geometric series. I believe this is the equation. And of course, r can't be equal to 1. Okay, else you have 0 in the bottom and then it doesn't make sense. And this is fine because our r is 0.85, so this is okay. Our r is 0.85, so that's fine. Okay, so we're going to figure this out for the first 15 terms. Our first term is 21, and then we have 1 minus 0.85 to the power of 15 all over 1 minus 0.85. Just gonna plug this straight into a calculator, and you should get 127.77. And then to get the area, remember you just multiply by 1, because each rectangle has a width of 1. And then the total area of the paper, we'll say 30 times 21, which equals 630. And then we'll basically want to figure out what is the percentage of 127.77 over 630. And we should get 20.28%. Good. And that's our answer. This is some really cool stuff. It's an elegant questions. You really have to think. So they're not asking us at this level. They're not asking us to just apply things we learned in class, like, where they just give you information and say, oh, find the sum or find this term, or instead they're giving us a real situation. Well, I mean, this isn't really a real situation. It's not a practical, real world problem, but it just shows like how we can apply our knowledge of sequences in sort of because they're not telling us exactly what to do. Yeah, is what I'm trying to say. First of all, like, you're given r as a percentage, which is maybe different, and for like the last question, they don't tell you that you need to calculate the sum. They don't tell you need to figure out how many terms are in the sequence, but you have to do that anyways. So when you were learning these concepts, your teacher in class might have told you, given you a sequence and then said, figure out how many terms are in this sequence. But now with these harder questions, it's not direct. Yeah, you have to understand the question and what it's asking, and then try to pull on all your math knowledge to figure out a strategy of solving it. So it's a really good question. It shows how we can apply our mathematical knowledge to solve problems, because in the real world it won't be as direct as somebody telling you need to do this to get the answer. You need to think what makes the most sense to get to the answer. All right, anyways, this concludes question 2 and 3. I hope that was helpful, and I'll see you in the next one.